So today I'm delighted to introduce today's guest, who is most certainly one of the top experts around data-centric AI, and that is Alex Ranter, who is an assistant professor of computer science at the University of Washington. Now, some of Alex's work focuses especially on data management and weak supervision techniques for machine learning. While he's not researching and teaching, he's also co-founder and CEO of Snorkel AI, based in Silicon Valley, or Redwood City to be exact. And to date, they have raised over 135 million, quite impressive. And prior to Snorkel AI and University of Washington, Alex completed his Ph.D. in computer science at Stanford University under Christopher Rhee, and he earned his A.B. in physics down the street from us here at Harvard University. Alex, welcome to the show.
Seamus, thank you so much for having me on, and thank you for that introduction.
And Alex, I know you've spoken at ODSC quite a few times, and we're excited to have you back. We want to talk more about your startup. We want to talk more about your session at ODSC, but let's kind of get into it. So first and foremost, tell us a bit about your background and your research at University of Washington.
Awesome. Well, it's great to be here. I've been through multiple stages of said background and career attending ODSC. So really exciting to be continuing that trend. So I guess I'll keep it focused on data-centric AI, and I'm a bit of an embarrassingly one-trick pony these days because of excitement for this general theme, which encompasses a lot of what myself and colleagues have been researching and working on and building and putting out there in deployment with users and customers over the last 7+ years at this point. So I'll start back at Stanford when I was doing my Ph.D. with Chris Ray, who was my advisor and is one of the co-founders at Snorkel now, and just kind of take the high level perspective that we were taking then as ML systems researchers, where we often would kind of frame and orient our research directions by, a very simple question of what is blocking people in actually building ML that gets deployed. And the question or the answer to that used to be very much around the model and associated components in engineering, right? It used to be actually we were back around 2015 when I entered the lab. There's a lot of work on things like feature engineering, picking out the right attributes of the data that the model should look at. You could say that crosses over with data, but usually it's that's thought of as part of the model. Somewhat of a semantic difference, but either way, engineering the features, picking and designing and implementing bespoke model architectures and bespoke training algorithms to go along with those architectures. Actually, back then, really building ground up, homegrown systems for then managing training and deployment, because the space was very nascent at that point. So a lot of it was on this development of the models, the actual boxes that were going to make the classification or prediction or tagging that we wanted to automate, and or the kind of MLOps infrastructure that would actually train and serve these models in production. And the data was thought of as kind of exogenous to this process, something that was someone else's job to worry about, right? Especially back then, but in many areas today, it's data sets, and in particular the what we call training data sets, the labeled training data that these models fit to and learn from to do their task. They're kind of thought of as something that you just do before the machine learning starts, right? I often think of this as kind of the Kaggle era of machine learning, which is I just download a Kaggle data set and then I start my actual machine learning development, or I download one of the academic benchmark data sets, or if you're in industry, I get some labeled data points from my subject matter expert colleagues in the business, and that's their job, and then I start my machine learning. And this used to be okay, right? But we started to see this trend where a lot of the kind of trade-offs in ML were being flipped on its head. A lot of the the models were getting, rather than trying to make them very efficient and be very smart and sparse about how we built them, we're just trying out these gigantic, increasingly deep learning models that had hundreds of millions or billions of parameters. In return, they started getting pretty amazing results, and doing so with pretty minimal human intervention on traditional model-centered tasks. But there's always a but. The trade-off was they were increasingly data hungry. So I know that's a bit of a long preamble, but we kind of took a step back and said, what if the models are actually becoming more push button? A lot of this is going out in the open source in really an unprecedented way. If you think about just computing technologies in general, what if the models become push button and pretty powerful and fairly kind of open source accessible and commoditized, where does AI development go? What do AI developers end up spending their time on? It seemed like the writing on the wall said it would be the data, labeling, developing, sampling, slicing, augmenting, relabeling, all the stuff that, the kind of unsexy stuff that was not machine learning proper. We said, what if that actually becomes the center of ML development? So that's kind of what the data-centric term meant in our mind, and as others are expressing it, well now. It was, what if the center of gravity and the actual thing you were developing and iterating on as an AI developer, ML developer, was more the data set than the model architecture. And that was kind of, imagine an hourglass in our trajectory. We started with the big picture question, and then we narrowed down to one common bottleneck around the data, which is labeling it. Right. So let's say you want to get a machine learning model to tag objects in images, or extract things from contracts, or classify things in a chest X-ray. You need to start with a bunch of data that's been labeled or annotated with the correct answer for it to learn from. There are other types of machine learning, but this, what's called supervised machine learning, is still the workhorse in real deployment scenarios, at least from our purview. So in this setting, you need that labeled training set, and that training set is very difficult to label, especially when you're working in areas where we did and still work, where you need someone who's very expert. Maybe the data is very private. Think doctors, lawyers, technicians, engineers. Very difficult getting them to label, 1 million data points to train a model and then relabel it every time something changes. So we said, okay, can we make this not go away, because we don't believe in that kind of, free energy machine kind of thing, right? There's still a human who needs to give information to the model. Even theoretically, you need to at least break some sign symmetries, even in the limit. But could we make this loop more accessible to subject matter experts? And can we make it look more like software development rather than, click, click, click for months? So this idea of making data labeling and development programmatic and faster, as a way to unblock data-centric AI, that's something that we've been working on now, then expanding out to other operations like data augmentations, slicing, sampling, the broader data-centric workflow through the Snorkel company. But that area was where we started, and it continues to be an area of work where some of the students I have the privilege to work with at UW are. We have a NERPS paper coming out on a lot of this stuff. We often refer to this as weak supervision. How do you take programmatic labeling that's radically more efficient and transparent and adaptable, but also messier, and clean it up in theoretically grounded ways? But that is the background in a nutshell. Maybe I'll pause there, because that's a big mouthful.
No, Alex, that's excellent. I've got, just trying to wrap my head around data-centric AI myself. I got so many questions around that, you just mentioned data-centric versus model-centric. I want to get into that. You brought up open source. You brought up the fact that this is coming out of academia. So I think we're going to have a great conversation around this. And again, I'll remind our audience that they're free to throw in their questions as well. So just to clear up a few things here, because I knew it's a pretty new term, been around the last year or two. I would say in academic circles, definitely longer. You had this big push in industry into data-driven AI, right? And for data-centric AI, you just mentioned labeling, which I know is a hugely important part of data-centric AI. You mentioned about large language models, which I definitely want to talk a little bit more about that. But just for people to get, there's a lot of different definitions of data-centric AI floating around there. And in my mind, and maybe I may be wrong here, what I'm reading about data-centric AI tends to be, it's more of a process. Some people call that a development cultural fit, but it's definitely training. It's definitely around labeling. But does it also cover validation, testing, the data pipeline flow? Like, yeah, if you can give us what your succinct definition of data-centric AI would be.
Yeah, I think it's a great question. So a lot of the focus that we've looked at has been around what often blocks teams, which is the training data set, these big labeled data sets that, the model fits to, learns from, right? The goal of a standard supervised machine learning model is to, fit but not overfit to a bunch of labeled data. So that's really, always been the heart of things. And what in our neck of the woods we mean by data-centric AI is it's really it's a hypothesis that the average developer is going to need to spend more time and going to get kind of more leverage out of iterating on the data than iterating on the model. It's not strictly an either or, but again, it kind of is a thesis that you're going to get more leverage out of improving your data or your data set, labeling more data, improving the quality, improving the way that you're slicing or sampling or augmenting the data, et cetera, rather than, picking a slightly different transformer model. And again, this is all credit to the way that the model development has just taken off over the last couple of years, right? But most often today, that's where you get the leverage. So it's a hypothesis about that, and it's just the kind of then set of techniques that help you do this development of the data. Now, for us, we do largely focus on the training data sets, but I think it's absolutely correct that and very exciting as an area to explore, because there's so much to explore in this area that looking at testing and evaluation data sets and thinking about other aspects of how the data is developed and processed is super interesting. Actually, my co-founder and former advisor, Chris, in the intro to ML course at Stanford, started putting in, some notes about, test set engineering, because a lot of people, again, are used to, the test set is something I download from a benchmark, and then I just get a score that gets, spit out at the end, and it tells me how well I do. But actually, even engineering the data sets that you're using for evaluation is, as you could imagine, hugely important. You need to make sure that it's sampled in a way that reflects your deployment environment, that it's refreshed, that it's monitored, et cetera. So I absolutely think it's more expansive than just a training set, although that's often what we focus on, just because that's the kind of 0 to 1 blocker to actually get a model built.
Yeah, and absolutely. Your work going right back to your PhD, you've been well ahead of the curve on this. But it's interesting to me. I think Andrew Ning, I was looking at a blog post of his, was it June of this year, June of last year? I can't remember. But he mentioned the number you said, 80% of machine learning data science time is spent doing, data wrangling, data transformation, even before you get to the feature engineering. And I remember quoting that number myself, an event we did in New York like 6 years ago. So I forget who did the survey on that came out. But it's a number that's been quoted now and again, and it's funny. It's been, surveys have come after that, and so the numbers go up, they go down, and then the definitions of what is data wrangling and what part happens in there is interesting. But in my mind, and a lot of practitioners' minds, I'm sure, data has always been so important, right? Because what is AI? It's data plus code, right? Math or whatever. But data has always been a big part of the equation. So what's interesting for me is like, why is it getting so much attention right now? Like it's like people want to have a movement around it. It's not just another topic. It's a new paradigm. Like, why is it getting so much attention now in the last 12 months? Why are people so excited about it?
It's a great question. I think there's a technological aspect, and then there's a cultural aspect almost, which I think Andrew does a much better job of kind of articulating that part of things. And he's been an amazing force to kind of, lead that charge and bring it out into the broader community. But I'll touch on it briefly. I think on the technological side, it really just has to do with, a lot of this is driven by the tremendous explosion in progress and convergence around machine learning models, right? So again, if you think about it, it used to be that, if we were starting the academic side, if you went to any of the kind of ML or NL, especially NLP or computer vision or applied conferences, and you looked at the average paper, they were about, specific models or specific types of features that did really well on specific tasks. If you wanted to, solve some problem X in industry, you would have to build a specific, specialized model for that, right? So the model was the kind of blocking point, and it was where you had the kind of differentiation in how well your solution worked. Now we've had this just tremendous process towards not only models getting more powerful, more automated, but also more convergent, right? Now, lately everything is a transformer, and then we go on to the latest variants. And if you look at state-of-the-art results, the models are very, very similar across a huge range of applications and data sets. So you've had this thing where, you can kind of start to hold the model fixed, and you're not going to get big gains often in many problems from, tweaking the model architecture, and you may not even be able to practically because they're so massive and black box. So I guess that trend towards everyone kind of using these more powerful but less modifiable and much more standardized models, that are also more data hungry. The blocker and becomes the fact that they need all this labeled data, and the interface point to actually change or edit something becomes the data, because you can't really do it with the model. The model's fairly fixed, right? So we've gone, from the data being kind of viewed as fixed and the model being the thing you're iterating on, to the models kind of being fixed and the data necessarily becoming the thing that you iterate on. So I think, and then I think so that's the technological aspect, is because of this big kind of driver of model progress and convergence, but leading to much more data hungry and less editable models, the data becomes it has to become the interface where you're both stuck on, but where you actually develop things. And then we're trying to catch up and build the tool sets and the platforms that support this, this kind of new central pain point in workflow. I think the cultural aspect is also just because, data engineering is so often just kind of at all parts of the pipeline, whatever kind of way you slice it up and name it, is almost always kind of thrown under the rug and treated like a second-class citizen in ML development, right? The fancy ML models are the things that we get taught about in our courses and that seem really exciting, and that, the at least up until the last couple of years, all the fancy machine learning papers get published about. I think there's a little bit of a exciting sense of relief from many practitioners that, dealing with the data is once again kind of getting recognized as important and worthy of support and study and formalization. And again, this idea that data is important is not totally new, right? Actually, I love an example from I think maybe it's a decade plus ago, that when people were working on actually the old school version of language models, they had all these sophisticated models that they built, and then Google came up with one called, I think, Stupid Backoff, and just trained it on 10 or 100x the amount of data, and it blew all the other ones away. So this idea that you can beat a fancier model with just more better data is not fundamentally new, but the pendulum has kind of swung back given these recent trends in the environment to that being the reality, and now we're trying to build around it.
No, and I think again, you just give me so much to think about and talk about, Alex. Yeah, I definitely want to talk more about large language models, because it's obvious that that's driving some or a lot of the interest around data-centric AI. But it's also interesting too when we talk about the model-centric approach and freezing the models. And I definitely see from your work, it's a dual approach. So I see challenges there because machine learning is still advancing. There's new platforms, new tools coming up. Despite what Gary Marcus and others are saying, that deep learning is going to hit a dead end, it seems like one way out of that dead end is bigger and bigger models, billions of parameters, soon to be trillions of parameters. So it's an interesting paradigm in the sense that even though I think data-centric AI is trying to simplify parts of the machine learning workflow, and but in some senses it's also complicating as well, right? Because it's not as simple as just freezing the models, because you still have to find the right models. Different models are going to perform under differently under different data sets. The cross-validation is still going to be very important, things like that. So do you see this as easing the workflow? Do you think AutoML is going to help here? You see a lot of no code, low code coming in. To me, it's like it's continuing to get more complex, even with data-centric, hopefully simplifying some of this stuff. Perhaps
yeah, great. Well, no, I mean, great points there, and those are the important things to anchor on. Are we actually making things simpler in practice and more practical, right? That's what all of this should be anchored on, right? So a lot of what we're doing in the data-centric, AI side of things is kind of all predicated on a bet that the model-centric side of things is going to become more and more accessible, right? So that is this convergence of models out in the open source, that work, out of the box for more and more problems. Again, I'll just reemphasize, it used to be that if you went to a person at a bank working on some kind of, analysis of 100-page contracts, then you went to someone working on, clinical trial data in a science lab. They would be using entirely different models. Now everyone's using the same transformer model from, the same open source repo, right? So this convergence really is noticeable. And that is one way of making things easier, because you don't need to build custom things. You can just kind of take one of these models and just start using it. And then AutoML, which is really also becoming, standardized, is further easing that, because let's say there's a couple of, models and parameters you might think of tuning. You can now start to automate all that if you have enough training data, right? So you can use these powerful kind of convergent models. You can use AutoML that even handles the tuning and selection more automatically if you have enough data. So that's kind of where things have shifted. If we can get data-centric right, then, the natural relationship is that the model-centric part in many, not all, but many use cases will become increasingly easy. Now, on the data-centric side, one pitch I'll make for why we should feel really optimistic for it becoming, for kind of making the overall picture easier and more accessible. Actually, I'll make 2 points. Number one, people were always doing this. It just got kind of shoved under the rug, right? Someone always had to label the data. And there were always, because data-centric AI, the ideas that we build around and pursue is that it's not just a one-off process. You're always going back and you're relabeling, you're editing, you're cleaning up, you're going back and forth. Like, this always happened. It was just, either not done for problems where the people to do the labeling were too expensive and busy, or it was happening behind the scenes, right? So this is always a thing that had to happen. It's more painful now because you need more data for these powerful models, but supporting it better is only going to make something that was already happening, better supported and easier, we think. And number two, one thing in the many data science projects that I've gotten to be, looped in on, one of the biggest blockers to things actually getting to production, in my mind, is a simple one of the data science teams not collaborating with what we often refer to as the subject matter experts. You want to ship something in medicine, and then the doctors are not talking with the data scientists, right? And they're just kind of throwing data sets over the wall. Hey, could you label a data set for me and I'll get a number out, right? Again, in the model-centric world, just having the data be this thing you throw over the wall, it's a great API. It's great for building your models, but it's not great for actually getting things across the line and collaborating. Data-centric provides us, if we build in the right way, for a great opportunity to actually have a common platform for collaboration between these two critical stakeholders in ML. Because, a subject matter expert who knows the data can actually interact with data-centric approaches more than they can do with models, right? A doctor, let's say, is more comfortable kind of, labeling and editing their data that they know versus, statistical features of a model. So again, those are two pitches maybe for why it's not just kind of shifting the buck around, but actually can make the process fundamentally easier. So again, just to summarize, as data-centric grows, it powers more of the automation of model-centric. So that becomes easier. And then the burden, of course, gets shifted to data-centric, but because it's around the data, which is a more kind of common ground for folks, we actually think that can become much more accessible. That's a lot of what we're building at Snorkel, building no-code interfaces so that subject matter experts can get looped into the process and help label data and develop data. They can even use natural language inputs and explain what they're looking for to label something some way, which is one cool result that we published about recently and in the past. So we think data is going to be a more accessible interface than models also. Yeah.
No, again, Alex, excellent point, because you bring up another good arguments there. One being, which I've always felt myself, like my background is in software engineering, and then before I was in machine learning, and it was quant finance. And domain expertise are always important in engineering, right? If you're working in healthcare, retail, finance, what have you. And yeah, the early days of annotation, it was just, go in Mechanical Turk, throw a couple of cents at each label, and then hopefully they'll label it as well as possible. But we're moving well away from that, because you just brought it up. Large language models. Now we're looking at people are moving into millions or billions of data points that we have to manually label, which is not possible. So So when you talk about domain expertise in annotation, when you talk about these massively large data sets, which is not possible to actually manually label them, like what's the alternative? Like what are the tools here for doing this? And I think you touched upon it a little bit. But yeah, so I've got 1 billion data points. Where do I start?
Well, let's talk about large language models for a bit, because you brought that up a couple of times, and we're quite excited about it as well, and have some papers that we posted and are coming out on the research side, and also are actually helping our customers on the enterprise side through the Snorkel company actually get value out of large language models on real production use cases, which I'll talk about in a second. But I'll make 2 points here. So first of all, large language models, one of the things that's exciting about them is that they're self-supervised on unlabeled data generally. So they don't actually need labeled data. But what we're seeing is, surprise, surprise, a lot of how well these things work still comes down to how you select and curate the data. So if you look at, there was the awesome release of Stable Diffusion. If you look at the release blog post, you'll note that one of the big factors was a carefully curated data set of beautiful images that went into to train it. OpenAI had a model Whisper recently where, again, the model architecture they used was pretty standard, but the data curation and collection was where some of the innovation happened. So even in these large language models where you're not blocked as much on labeling the data, curating, collecting, sampling, so developing the data is still one of the things that actually differentiates success from failure, and is actually a lot of where the innovation happens. So you're still seeing this data-centric kind of vector happening. And then back to labeling data and developing and a lot of the other things we work on, getting these large language models to work in a high accuracy, bespoke production environment is still challenging, right? One of the terms that my co-founder Chris over at Stanford and others have coined is foundation models, or I don't know if they coined it or someone else did, whatever it is. It's a Twitter battle I won't get involved in, but it's a nice term for them. First of all, because they are going beyond language, so they're becoming multimodal, and that's one thing that's obviously super exciting. But also because in a lot of production use cases, the type we build around, they're the foundation for things. They, like any other pre-training or transfer learning approach, they help you get started. But if you want, some model like GPT-3 to work on, say, classifying complex legal documents in a bank or complex medical documents in a hospital system, you need to fine tune and adapt it, which, surprise, surprise, takes more labeled data or prompting or some kind of data engineering. So even with these large language models, the big innovation vectors around them are increasingly around data rather than the specific model architecture, which again is becoming more and more standardized. And B, then when you actually want to get them to work in some real use case with high accuracy requirements and challenging data, you once again have to come back to data development, and they give you a nice head start, but that still becomes the bottleneck. So that's a little bit of perspective on how they kind of fit into things. And maybe I'll pause there for a second, but we're quite excited about them. And it's a big focus of a lot of our customers on the company side now are they're saying, hey, I want to we want to, how do we use GPT-3? Like we can't deploy it in our environment. It doesn't work out of the box on the majority of our problems because they're too complex and specific to our highly technical setting, but can we get something out of it? And the answer, and I'm actually going to shameless pitch for the ODSC talk, I'm going to talk about some of the work in my talk at ODSC, is you can use them to accelerate data-centric AI development and have them kind of supercharge it, but ultimately, really get high accuracy specialized models that you can deploy in the enterprise at the end of the day. So I'll leave that as a teaser for what I'll talk about in part on
No, excellent. And I do want to get into we talked a little bit about Snorkel AI, which was started as an open source project, and but going back to your point about GPT-3 and other tools out there or services, so a lot of the open source frameworks and tools and a lot of the proprietary platforms out there have been, I guess we could say, notwithstanding interfaces and plugins to data lakes and big data. So my comment here can be a little bit debatable, but in my view, they've been kind of model-centric versus data-centric, if I'm understanding everything that data-centric encompasses. So do you think we have the tools and the frameworks for companies to be do more data-centric AI? Or do we need to retool? Do we need different tools? Again, I know Snorkel AI is ahead of the curve here. Do we need new tools? Do we need to think about the machine learning, data science workflow, which again may require new tooling? Just as we're getting used to the whole ML ops paradigm, do we need to rethink that a bit? Yeah. So where do you stand on that? And I know I'm wrapping a lot of points in one, but just would love to hear your insights.
Yeah, I'm obviously highly biased, right? Both because
That's okay.
because of yeah. I mean, that's why I guess I'm here to talk from said biases. But both from the company side and also from the academic side, we're on both fronts. I think there's a tremendous gap in terms of tooling and workflow support and platforms for this new type of data-centric AI. I don't think it means that we throw out everything. I mean, again, the goal here is to enable everyone to use all of the great progress in models and ML ops, right? That's why a lot of the way that we do things, again, it's oriented around getting the models the data they need, and then working with the existing models that are so well supported for both training and deployment, right? We want to use all of that ML ops stuff and all of the great model innovations, which are, again, in our view, increasingly becoming standardized and increasingly accessible and increasingly powerful, but also data hungry. So, again, I don't think it's definitely not about throwing out the kind of old tooling. It's actually quite the opposite. We want to let more people take advantage of that, right? There's so many use cases out there where, I mean, again, let's take a step back and say, I'll pick some random examples. Why do we hear often a lot about customer churn prediction, for example, or, predictive maintenance? If you're on the federal side of things, you hear about a lot. Well, it's because that data is often already labeled and nicely curated. When a customer churns off your platform, when a ship or a vehicle breaks down. But there's this vast kind of iceberg under the surface of use cases where people don't have nicely labeled, curated data, and they can't use all of these great ML tools out there. So we're not trying to get rid of those tools. We're trying to enable people to use them by filling this gap around the data development. And for that gap, I mean, again, I'm biased, but I absolutely think there's a ton of white space to fill, because again, this has been entirely ignored by the community building tooling for machine learning workflows, right? The idea, just even the basic idea that the data set is something that you're going to be going back to and editing as a core object in your workflow as you're building a model is something that we just haven't thought about, right? You look at ML platforms by default, they just accept the model as some input that then stays fixed while you're developing your model, right? The idea that it's actually the center thing that you're changing and iterating and then giving tooling to do that efficiently and in ways that are, look more like good software development practices versus just, typing in labels in an Excel spreadsheet for a couple of months. That doesn't exist. And so that's obviously what we're trying to fill with what we're building at Snorkel. And I think there's a ton of white space for many to fill on both the academic and commercial sides in this exciting new area.
Yeah, we could talk all day about this, Alex. I was just last night filling in labels on an Excel spreadsheet still. So, but just talking about the Snorkel AI. So this originated as an open source project, I believe, out of, was it Stanford or University of Washington? But yeah, and now you're quite a successful startup. Tell us about this journey, which is, I think, is fascinating, because we at ODSC we love to support excuse the pun here, but open source centric startups.
Yeah. Let me jump into it. And also just in the spirit of calling out comments and questions, just wanted to note a comment that I thought was great in the chat from Sarah about getting into more complex projects and realizing that data scientists have to spend time on kind of understanding and labeling the data, and that even just properly scoping your project can be impacted. I just wanted to call that out as something that rears its head when you're in the data-centric world. ML is so used to just having nicely pre-labeled data with clear definitions of what you're trying to label that we've ignored so much of what actually blocks projects. It's not even just labeling the data or developing it. It's defining how to label it. I've never seen a real world project where there's not significant and multiple edits to even how you're labeling the data, right? I'll give an example from one of our customers, the top 3 U.S. bank. When they started before using our platform Snorkel, they were, I think they spent about 6 months labeling data for an 8-way classification problem. I'll just leave it, high level like that. And they finally got it across the line 6 months later, again, per the data-centric thesis, 6 months labeling data in Excel spreadsheets, a day or two using an open source document classification model that they got from, I think, an intro to NLP course at Stanford, right? So again, model was not the blocker, data was. They ship it, and the line of business team comes back and says, great, we have a 30-way classification problem now. So we decided we needed to split a bunch of those classes. I've never seen that not happen. So it's not even just the labeling or the development, it's also the back and forth of taking just raw, unstructured, unlabeled data and deciding, how should we be labeling it? How should we be structuring this problem? And when you move away from these kind of benchmark data sets where it's all set up for you, you realize this is a lot of the make or break stuff. So data-centric is about supporting all of that as well. And that, of course, is also requires collaboration with the subject matter experts who define the problem. And so anyway, just wanted to note on that quickly, because I think it's a great point to touch on. All of this stuff gets uncorked, all this mess, when you actually go into the data-centric world. But back to the company, I can talk briefly a little bit about that journey. I mean, I think we were, so first of all, we have always been, very anchored in open source and in particular in, from the researcher perspective, in having, open, reproducible artifacts for the open research that we publish, right? So, one common misunderstanding that I think we get sometimes, it's a, small distinction, but important, is that, we put out, we've put out and we still put out dozens and dozens, probably hundreds at this point, of open source repos. We have about, I think over 70 papers from the core Snorkel team, and extended team now. And each one we try to put out an open source repo with. Recently, one of my students at UW, Jie Zhang, put out a repo called Wrench that enables, evaluation of what we call weak supervision or programmatic labeling techniques. So we're always putting these things out there. One of the repos that we did back in 2017, along with a 2016 NeurIPS paper, kind of took off in terms of people using, and it's been super exciting to see. It's worth noting that, we've always operated as researchers, right? So our repos are meant to be just kind of, research skeletons to let you kind of play around with the ideas in a paper. But anyway, that kind of putting out some minimal open source stuff along with our academic research that we publish is something that we continue to do, both on the academic side and through the company, where we've been posting some papers to archive recently. But then I guess that started to take off, and we started to get pings from venture capitalists who we were, for a couple of years just completely ignoring. But we started to hold office hours for various users, and they became quite crowded. We had weekly office hours, and we were trying to help people use these new programmatic labeling data-centric techniques through some of the open source and other research projects. And eventually, we started getting feedback from our users, kind of saying almost like, "Hey, that's great that you're publishing another paper on these statistical convergence bounds on this or that, and that's really cool and all. But like, could you make us a UI, or could you give us some guidance on feedback loops of error analysis, and where do we go next to iterate? And can you help with the data management and with the first and last mile stuff, and like all the kind of product platform issues?" When we worked with especially applied data science users who were trying to get something done, a lot of them at the time were doctors or scientists or journalists or folks at NGOs, very smart, sophisticated people, but they had actual things they wanted to build, and they were saying, "Hey, could you build that maybe?" So when we started seeing that, and also with industry partners, we wrote about some of our deployments with Google and Intel and others. We started realizing that it was a lot more than just an algorithm or an idea. It was really about supporting this new workflow where you had to label and develop your data. You had to get feedback from a model. You had to have guidance on where to go next. You had to have support for this whole loop. And that was kind of more of a productization or platform kind of objective. So, and that's not what a research kind of setting is set up for, just in terms of what's fair to put grad students to work on and what we have capacity and funding for, et cetera. So that was when we actually poked our head up and, started meeting with some of those VCs and decided to spin out. That was around 2019. And we're still just incredibly excited and pushing on the academic side. But now the mission of the company is really to actually turn that into a platform and a product that can get people working on, high value, high complexity projects to, practical outcomes in, very efficient, development cycles. And we think a lot about anchoring on specific use cases, and we think a lot about the practical realities of, per Sarah's comment, how do you even scope the problems? How do you edit and modify them? How do you support the collaboration with the business people or the subject matter experts? How do you get things really shipped end to end? So while we're still very focused on the data, and data labeling is often a pain point, we actually now build an end-to-end platform that helps people actually just go through this whole data-centric cycle. And they can always interoperate with modeling platforms, et cetera, but we try to get them end-to-end with this way of doing things. And we've seen some pretty exciting results on that front. So it's been a really exciting journey so far.
Yeah, and again, congratulations, Alex. And that's a great story how it went from an open source project to user kind of demand. And yeah, we always say, build versus, trying to figure out how much effort you want to put into open source projects in terms of trying to get into production can be, they work great on your workstation laptop, but getting into production can be quite the challenge. And Michaela did have a question on what tools you use to label the unlabeled data and what approach you recommend. I think it's obvious. Don't use an Excel spreadsheet like I do. Instead, use Snorkel AI. But if you had any other insights on that, please feel free.
Yeah, I mean, I'll try to answer in a way that's a little bit more interesting than just saying use Snorkel or use Snorkel for our platform through the company. Now, I think that one of the core questions to ask is who do you need to do that labeling, and how difficult is it going to be, right? Factors that we often think about are, do you need a subject matter expert? Do you need a doctor or an underwriter or a network technician to do the labeling, or is it cat versus dog versus stop sign, where maybe you can use Mechanical Turk or the other kind of variants of that is many companies kind of built around. The second factor is often how private and or complex is the data? Is this a very generic open source data set where there might be lots of pre-trained models and things like that? Or is this really private custom data that you're really going to have to train more from scratch on? And then number three is, how often is the data going to change? Is this something where you can label it once and you'll be fine? Or is it constantly going to change? So a lot of the things that we build for, just to be transparent, are these settings where it's not so easy to do the labeling and development. You need subject matter experts. You have very complex data that lives inside a hospital system or a lab or a bank or a government agency. Pardon me. And you have data that is constantly changing because the world is changing. The requirements of what you actually want the model to do are changing. When you're in that setting, manual labeling, no matter what interface you put around it, is a very tricky thing to scale. Very, very difficult, because how do you edit a pile of labels? Well, the answer is you don't really, right? Machine learning models learn globally. If you want to edit something, you got to really throw out and relabel the whole data set. And that's where, the programmatic approaches of labeling data, making it look more like software development, having your data be labeled by a software artifact that you can both build quicker, but also build more rapidly, but also edit and audit and change. That becomes quite critical. And that's what we're building at Snorkel. But of course, if you're saying, look, I just want to categorize, Yelp reviews as positive or negative, there are, maybe, kind of old school ways of just, doing manual labeling or outsourcing it are fine there. Yeah. Hey, Seamus, I think you might be on mute.
Yeah, I think that's an excellent answer. I think the programmatic approach is definitely the future and the trend. So, Alex, you've given us great insights today, but unfortunately, I've kind of interrupted your flow of conversation here. So, but you will have a chance to speak at ODSC West, where the audience will have your full undivided attention. So, tell us a little bit more about the session coming up at ODSC West.
Awesome. Yeah, well, I'm really excited about it. It's definitely going to go a little bit more in the weeds. So, fair warning. But I'll still kind of, try to give some broad overview. So what I'll be talking about, the title is Operationalizing. I'm glad you put it up here because I might have forgotten the exact permutation of the words when I was filling out the form. But operationalizing organizational knowledge with data-centric AI, and a lot of what we've always been motivated by is how do we use existing sources of knowledge and information to accelerate this data development and labeling and ML process, right? So a lot of projects get stalled because they're seen as a net new effort every time to just kind of get someone to label data for by hand for a couple of months before anything gets started. One of the motivations we've had through the Snorkel project and other lines of research and what we're building at the company now over the years is how can we leverage what you already know and what you already have. And so I'm going to give a survey of some of those cool ways in which you can use these existing sources of knowledge. You can use large language models. You can use knowledge bases. You can use legacy rules-based systems. You can use even manual labels that you might have sitting around. You can kind of dump these all in to a platform like Snorkel and use them to rapidly build new models for new target use cases. And this does connect to the kind of weak supervision programmatic labeling work, but it's kind of showing a lot of the more advanced ways of doing it using these existing sources of knowledge. So that might have been a little bit vague and high level, but if you're interested in more, please check out the talk.
No, that was very cool, Alex. Looking forward to that and seeing you in person at ODSC West in, I think, 4 short weeks. So I'm going to stay on with our audience a little bit because there's some follow-up questions there I'll just address. But Alex, thanks once again for being on the show. Thanks for being an ODSC speaker. I think this is your second or third appearance at ODSC. So thank you so much. Looking forward to catching up with you, and thank you for giving us such great insights around data-centric AI.
Seamus, thank you for having me on. Thank you, and the folks in the comments for the great questions. And I'm really excited to see you all in person at ODSC.
All right, Alex. See you again.